You're exhausted, you can't focus, your brain feels like a great fog. And then suddenly, next class, PE. You move, you sweat, you laugh, and you come back to school, and suddenly you can learn and memorize things much more effectively than before. That is not random. That is the biology of learning connected with motion. But how many of us are actually aware of how important physical activity is? Well, according to the data, not many. Because researchers from the World Health Organization have found that over 80% of adolescents fail to meet the global standards of at least 1 hour of physical activity daily. And I cannot stress this enough. That does not mean intense physical training. It simply means going for a run, a bicycle ride, or a walk. What can you see on the picture behind? Does this situation look familiar? Studying for a test or doing your homework to the point where you have no idea how to overcome the block. Another unproductive hour passes as you read the same sentence over and over again and try to make sense of what you had just read. Or you stare at a difficult math equation and you have no idea how to try to solve it. Then you get up. You pace your room a few steps back and forth, maybe go to the kitchen and fetch some water. You come back, you sit back down at your desk, and suddenly the answer just comes to you, and it becomes clear what you need to do next. So today, I would like to present to you exactly what mechanisms in our brain are responsible for this effect and how physical activity activates them. Well, obviously, this effect is much more visible after longer, prolonged periods of physical activity and if we are consistent. So for a long time, I was actually believing that the processes of learning and memory and physical activity are separate in our body, managed by distinct systems in our brain. Yet from an evolutionary standpoint, those two things have to be connected in order to enhance survival. So physical exertion often occurred in moments of stress, when we encountered some kind of danger, and we needed something more than just quick movement to overcome. We needed heightened brain activity. So increased brain plasticity helps us analyze the situation, adapt to new unknown stressors, and analyze the environment in order to learn from our mistakes and actually learn how to avoid those same mistakes in the future. So let's start with exactly how physical activity affects our brain. At the center of today's story, a study from 2011 conducted by American neuroscientists which focus on the relation between physical activity and the volume of the hippocampus. So, what is the hippocampus? Well, when we think about memory, we often imagine something completely abstract, like we store things in our brain, but that is not entirely true. Everything is coordinated by the hippocampus, which is a 5-centimeter curved ridge of gray matter located deep in our temporal lobe. Together with the rest of the limbic system, the hippocampus helps us encode, store, and retrieve information. Together, those structures help us how to remember the date of the test, and they also only had math a few days before, or they help us recognize the songs from just a few simple notes. So the point is that it's 2011, those researchers recruited aging adults to participate in their study, and they encouraged them to participate in moderate aerobic training 3 times a week for a full year. And after those 12 months, what happens? Well, they observed that the participants' hippocampus literally increased in volume. They found that regular physical activity changed the structure of this very part of our brain. And imagine this. If the adult brain can respond this positively to movement, how much more can our young, still developing brains respond to this? It's absolutely amazing because the researchers found that the volume of the hippocampus in the participants who exercised regularly increased by 2% over the year, while usually in aging adults, we see a 1% decrease. So the difference is really huge. And also, the participants underwent spatial memory tests, and their performance in those tests was much better than in the case of those participants who did not exercise. And let's take a look at what else we can learn from this study. So, researchers suggested a link between physical activity and the synthesis of the brain-derived neurotrophic factor, BDNF for short, in our brains. And the key thing here is that physical activity actually helps us to synthesize more of the BDNF in our brains. So how does that work? Well, it all begins with the simple statement that physical exercise requires energy. When we are tired, we need something that fuels us, and our bodies adapt to it by increasing oxygen consumption and metabolism. This, in turn, leads to the production of ketone bodies for our livers, and interestingly enough, one of such ketone bodies has been found to be transported through the bloodstream to the brain, where it then participates in the synthesis and expression of the BDNF. So when we examine a study that tells us that yes, those results were significant, and regular physical activity can actually help us increase the size of our brain and synthesize more of the BDNF, we now know that physical activity is actually very important for us. And now let's take a look at this whole situation from a bit of a different perspective. Because every day we encounter many stressors, every hour, every second. Tests, exams, pub quizzes, notes, difficult conversation with friends or with our parents, and our bodies have to respond to them. So the way that it works is that we have two different mechanisms of response to such situations. The first one is the SAM axis, which is basically the quicker response mechanism. It manifests itself through direct changes in our bodies, so for example, increased heart rate, blood pressure, or sweating. This is evolutionary, sometimes called the fight or flight mechanism, and was useful when our ancestors encountered a very dangerous situation and they had to act quickly and think quickly. And this is sometimes called fight or flight. And maybe we have it when we are watching a horror movie and the jump scare knocks us completely off balance. Our heart starts pounding, but after a few seconds or a few minutes, we kind of forget that the whole situation happened and we go back to normal. The thing is that we have another response mechanism to stress, which is the hypothalamic pituitary adrenal axis, the HPA for short. And we all have heard numerous times that acute stress is detrimental to our mental and physical health. Because the way the HPA axis works is that it produces cortisol. And the dysregulation of the HPA axis has been widely associated with neurodegenerative diseases such as Alzheimer's, Parkinson's, or multiple sclerosis. And the positive thing here is that physical exercise can actually help us regulate the HPA axis. So, firstly, let's focus on what cortisol is. It's a powerful hormone that stimulates our body and motivates us to keep going. However, we can compare it to kind of our internal fire alarm. When it goes off, we know that something is wrong and we need to act now. But it's only good if it goes off for the right reasons and only the right reasons. So if it's constantly there in the background blaring, we cannot focus on anything. Our concentration is disturbed and we cannot think clearly. And it's the same way with cortisol. When we know that it's useful, it's good. However, if it's constantly there, if we're constantly stressed out and producing cortisol, it disrupts every process that's going on in our body. And physical activity can act like a vaccine for cortisol. Because when we exercise, we also produce it. However, it's predictable for our body. Our body knows when it will be produced and how it will be used, and then how to dispose of cortisol. So our bodies adapt to it. And then, when we encounter a situation that is really stressful and that we're not so well prepared for, our body knows how to deal with the increased levels of cortisol and how to get rid of them later. So now, maybe allow me to introduce to you two twins, Casper and Nico. In school, they have basically the same grades, the same notes. They don't vary from themselves that much. However, Casper is the one that has track practice 4 to 5 times a week, while Michal spends his free time scrolling through social media. Now, both of these brothers find themselves in a situation of great stress, where a lady nearby faints, simply loses consciousness on the street. One of these brothers calmly takes out his phone, calls the ambulance, and tells what happened, where it happened, and does everything that the lady on the phone tells him to do. However, the other brother, sits down on the pavement and starts tugging at his hair because he is so stressed out that he cannot think clearly. He has no idea what to do. And now, let's take a guess which one is which. Well, if you thought that Casper, the one who practices, was the one who called the ambulance, you were right. And, well, it's all connected to what has been said before, that physical activity acts as kind of a stress vaccine. So he was used to having cortisol in his body, and it didn't cloud his thinking. now let's maybe go back to the situation when we were still young and discovering the world for the very first time to actually help us understand better what is happening here. So we were on a walk with our parents and we saw a dog, something we had not seen before. It was enormous, it was barking really loud at us and spit was flying everywhere in every direction. So obviously we were scared, we did not want to approach the dog, we wanted to go as far away as possible. But our parents held us by the hand and told us everything was going to be okay, yet we still went around, we did not want to go close. But then, the second day we come back to the exact same place, and we know that nothing happened the last time, so maybe we'll be safe this time too, so we don't want to run away, we're still very scared, very tense when we go past the dog. The third and the fourth time, we may start noticing that the dog isn't even that big, and it isn't even barking that loud. The seventh and eighth time, we may stop by the fence and smile at the dog. The 20th time, we may even give it a little pat on the head. And do we even notice the dog the 50th or the 100th time? No, because we got so used to the dog that we know it's going to be there, and we know that nothing bad will happen to us when we go past it. So basically, there were also many studies in the literature that found that people who exercise regularly, who participate in this moderate aerobic training I mentioned before, could perform better under stress. So when they took, for example, cognitive performance tests under pressure, their results were much better compared to sedentary controls who did not exercise regularly. So kind of to sum up what we learned here before, physical exercise can literally change the structure of our brain and help the become this expanded size, form new neural connections, and help in the synthesis of those BDNF control trainers in our brain. It can also help us adapt to everyday life, to stress, to stressful situations which we encounter on a daily basis. And now, what I want you to remember from today is that the next time you go outside, you go for a run, maybe you play football with your friends, and you're moving, visualize everything that we have talked about here today. Visualize how your brain literally is expanding in size. Visualize those little BDNF personal trainers being synthesized. Visualize cortisol being released in the body, then used in a successful way, then gotten rid of. And think about the story with the dog again. The first time you go outside, the first time you train, you go to the gym, it may be hard. But you will get used to it, and then it will only get better over time. Do not think of it as a chore, and do not think of it as purely doing for example, aesthetic reasons, for physical reasons, but you are doing it for the future. You are doing it for your brain, and I will be very grateful to you for that. So I hope that you remember that, and please visualize everything that you learned today the next time you're training. Thank you very much.